Okay, so this week we're going to transition into a method of proving validity that your textbook doesn't cover, and that's why I'm supplying you with some chapters from another textbook in order to show this. So last week you all learned about the truth table method, which is able to show you whether or not a deductive argument is valid or invalid. Now, that's a very good method to show you kind of the mechanics and just be able to go through and figure out what was valid or invalid. But the method has obvious limitations. First of all, as we kind of discussed last week, it's a cumbersome process. And second of all, though, while the truth table method can show you whether or not an argument is valid or invalid, it really doesn't tell you why that argument is valid, what makes an argument valid. And so this week we're going to work on what is known as natural deduction, or as it's sometimes just referred to as the proof method. Now, as you'll see going forward here, this method looks an awful lot like, geometric proofs that you might have done in a geometry class. Because again, what's going to happen here is that we're going to show that an argument is valid by breaking it down into the individual valid forms that are found within those arguments. But in order to get to that point, we should discuss these valid forms of arguments, deductive arguments here. So, as you probably saw when you're doing the truth table method, there are some forms of arguments, I should say, that will always be valid, no matter what. So there will never be a line on the truth table in which you have all true premises and a false conclusion. And those particular forms are the ones that are going to have, they are the valid ones, and they have particular names that go along with them. So let's, just for the sake of showing what's going on here, let's consider this form of an argument. So P horseshoe Q, P, therefore Q. Okay? So if we go ahead and we make our truth table here, you'll see that this argument is clearly valid here, so this form of argument. So true to true is true, true to false is false, false to true is true, false to false is true, and then we can just sort of copy the P and Q columns in their respective places. Alright, so again, if we go through the table here, we can see that every place where the conclusion is false, we can see it all checks out and it's good. So there's a false premise and a true premise here, false premise and a true premise here. So this, we can say here, is a valid argument. Now, this particular form of an argument has a specific name. And as the chapter discusses, this form is known as modus ponens, or MP for short. All right. And so, if you find an argument, any argument, that takes this form, you can automatically know that it's going to be valid because you can recognize this form here. So what's interesting about these forms here is that they can look wildly different from one another. Because essentially here, when it comes to the valid forms, and only the valid forms, whatever we plug into P or Q will not change whether or not it's valid or not. So let me demonstrate this. All right. So let's just say we'll make P equal to, instead of P, we'll substitute in something like, I don't know, K tribar M. Okay? And for Q, we'll substitute in, let's say, K horseshoe, and then O wedge Q. Okay? We'll take that out real quick there. So this. Right? So then we can plug it into this form here. Right? So K M, therefore O or Q, K tribar M, therefore O or Q. All right. So if we were to go in and do a truth table for this particular argument, we would see that it would still be valid. In fact, just for the sake of brevity, let's just use an indirect truth table to try to determine the validity of this. So again, we're going to try to make it where we're going to try to make the argument invalid here. So O or Q, and then K tribar M, and then K tribar M, horseshoe, O or Q. Okay? Alright. So again, we have all our letters out here. Okay? Alright. So let's see if we can't make this whole thing invalid. So again, our conclusion is a disjunction, so we're trying to make it false. So in order to make a disjunction false, both disjuncts need to be false. So we already got our values for O and Q. So let's go ahead and plug those things back in to where they need to go. Right, so O is the only one here. Oh, and Q, right? Right, so O or Q we automatically know is false. Alright, so the main operator connective here is the horseshoe, and if our consequent is already false, we need to try to make it where the antecedent, the left side of the horseshoe, is going to be false as well, so we don't make the whole thing false. So in order to do that, we'll need to plug in, certain different values, because this is a tribar, we need to plug in different values for K and M. They can't both be true or both be false. So let's just make K true and M false. So that would make it false. Okay, so we got false, horseshoe false, which then makes that true, so that works, cool. And then we go over here though, and we plug that in, and we can see that true, tribar, false is going to always be false, so the table doesn't work, and so that's our proof that this is valid. Okay? But again, it doesn't matter what you plug into P or to Q, and we use, again, to reiterate, I think I mentioned this last time, we use P or Q as sort of like our generic stand-in variables, and the way that you use X and Y in algebra, for instance. But again, no matter what you plug into P or Q, if it's in this form of the argument, it's going to be valid. Okay. So this is just to demonstrate that point, that it can look really hairy, really, kind of the whole argument, but the real kind of trick in all of this, and the selection from the book that I gave you mentions this, the trick to doing proof method natural deduction well is being able to see the forms within arguments. And that may take a little practice or a little time, okay, because these arguments can get progressively a little more complicated. This looks kind of complicated, but if you can figure out what the main operators are in each proposition, figure that out, then you can see if it has the correct form, right, as a valid form. All right, so in addition to modus ponens, there are a few other forms that you should know, just kind of as generic rules of valid argumentation. Okay, so again, these forms will always be valid no matter what you plug in for P or Q or R if there are more than two variables within a form, or S. Okay, right. So, for instance, in addition to this being a valid form, we also have this particular kind of argument. So again, we start off with our conditional, but this time we're going to negate. The second premise will be a negation of the consequent, and then therefore we then negate the antecedent. This is a valid form as well, and we refer to it as modus tollens, or MT for short. Another kind of form that we have, again, is a valid form, and all of these are forms that you should learn and kind of know in your mind, memorize, if you will, so that when we get into more complicated arguments, you can just sort of see these naturally. There's another argument that involves nothing but conditional statements. Okay, so we have P, horseshoe, Q, Q, horseshoe R, therefore P, horseshoe R. Okay? So here then, we can see that this, sometimes, so we call this particular form hypothetical syllogism. Or HS for short. Sometimes some books will call this a chain argument. It's kind of an interesting way of thinking about it because you see here is that you have the same letter, the same variable, and it's identical on opposite sides of each of these conditionals. And what this does is it basically, like, those two drop out, if you will, and nothing is left but the antecedent in the first claim and the consequent in the second claim, right? And then so that's why there's like this chain here that we use to demonstrate this, all right? So that's 3 so far. We have a couple more that are valid forms. So we have another one known as disjunctive syllogism. Okay, which basically again begins with a disjunction, P or Q, and then it says the second premise will always be the negation of one of the disjuncts, so not P, and then therefore Q. It's an either or, so either Nancy or Barbara are going to the fair. Well, Nancy's not going to the fair, so in order for this whole thing to be true, Barbara has to be going to the fair. Okay. All right. Okay, so the other kind of form that we have here is the constructive dilemma here. All right. That's our final kind of form to think about here. And by the way, the shorthand for the disjunctive syllogism is just DS. So we have a constructive dilemma, or CD for short. And it basically goes as follows. So you're going to have here basically P, horseshoe R, and, excuse me, let's just do it this way. P, horseshoe Q, and R, horseshoe S. Okay? That's your first premise. Second premise is going to be the disjunction of the two antecedents in the first premise. So in this case, it's going to be P or R. Okay? And then the conclusion of all of it is going to be Q or S. Here. So in many ways, the way to think about this, your book describes it as such, is it's almost like there's kind of like two modus ponens moves going on in this rule. So you have P drops out to get you Q, R drops out to get you S, and then you basically are able to get this conclusion here. Okay. So those are some of the basic forms that come in, okay, and they function as basically, in this case, it would be our 5 or the 8 rules of implication, which we'll talk about this week. So you've already learned at least 5 of those. Okay. Just a couple more things to note about these valid forms here. Again, you need to be thinking about what the main operators are in every argument and the form that it's taking. Now, when you're actually proving that an argument is valid, which we'll talk about here in a second, it may not be so perfectly neat looking. So let's just take, for instance, here, the easiest one kind of to remember, modus ponens. Okay. So we've talked about how, there can be different substitutions for P and Q. Okay, so you might have something like, I don't know, let's just say A or B, horseshoe C, A or B, therefore C. Okay? Now, within an argument, when you're proving it, it may not be in this nice order, because the way this will work is the premises may not be lined up like this is one, the first premise, and this is the second premise. You might have a weird case where maybe this comes first. This being the second premise comes first in the thing. Maybe there's another premise, I don't know, somewhere here, right? So maybe you have a premise like this, and then, oh, here's the first premise over here, right there. And then the conclusion, this is the way we symbolize this when we do proof method, the conclusion, we'll take out the tridots here, just use the slash mark. The conclusion will be C, okay? So you may have an argument that looks like this, and you need to find some sort of form in this. So it might be that it's out of order, but you can see here that, oh, look, you have here on line 1 the identical proposition as you have in the antecedent on line 3. Okay? So then you can say, all right, modus ponens here, and that gets you C. Okay? So you may have that. So again, ordering may not be exactly as it's shown in the sort of textbook rule formulation. Okay? The other thing that we need that should be kept in mind is the role of negate of tildes in all of this. So, for instance, say you have this case of modus tollens here. So you have, let's see, A or B, horseshoe, not C, C, therefore not A or B. This is still a case of modus tollens for the reason that with modus tollens, you're always going for the opposite of the consequent. And C would, of course, be the opposite of not C. Okay. Likewise, say you're doing something like hypothetical syllogism, right? So, to kind of switch this up a little bit, say you have something like this. Okay? Right? So again, as long in hypothetical syllogism, as long as the consequent of one of the conditional phrases is negated, is the same as the antecedent of another conditional statement, as long as they're identical, you can still do hypothetical syllogism. Okay? So again, don't let these tildes sort of, confuse you in how things are done. It's just about trying to figure out, just try to think of it in terms of identity between certain parts of statements.